Hi Vilasji. Hi Jobin.
Hi.
Abdav. Hi. Are you doing great? How's the life?
Yeah. Good.
Good. Let us start when your colleagues join within couple of minutes. Okay.
That's interesting.
Guys, it is requested if you could join by your real name, like somebody has joined with the Zoom user. So if you could join with the real name, somebody joined with the Jackson name. If this is your main name or a principal name, it's okay. But if it is not, actually, there's a company called Jackson in India, and throughout the globe it is known. So if you are not joining from that name, it's okay. Jackson, is it your real name? Jackson is not responding.
Yes, it's my real name.
Oh, great. Thank you.
Yeah, no worries.
Betsy Samuel, how are you? Kamran Ahmed. Tamil Selvi, have you joined for the first time, man? Tamil Selvi.
Yes, sir.
Okay. Thank you. So even right today, we are going to start something newer topic. You must have seen that we are going to look the world and its object from the eyes of probability. So that was we are going to say. Welcome, Kamran Ahmed ji. All well, I hope in your time. Yeah, great. Okay, let's start. Let the people join by their time. Let's start. Let me share the screen and do let me know if it is visible to you as well. Say mine is this. If I go to the main, one second, control F5, and here I go. Second, basic. Slideshow. Yes, guys, what do you say? Is it visible?
Yes.
Okay, thank you. Okay, great. So actually, I have taken this topic such that knowingly or unknowingly, we all are doing this, but we are not quantifying the things. We have only learned, okay, we learned this term, which is called a probability in our 11th standard, if you are a science student. So you must have learned this probability in your 11th standard. Yes or no? 11th to 12th standard. Some few glimpses are also being given in your 9th or 10th standard. Nowadays, the students are stressed with IIT JEE exam in India, especially. So they are preparing it from their 7th or 8th standard. But this probability, we have learned it by the name. Okay, if we toss a coin, we get a head or a tail, and then a probability becomes 1/2. This is how we learned this probability term. But have you ever imagined that if you have been given a certain roadmap, actually apply the logic, and then this logic takes you to the mathematical implementation of this. Say, suppose if I ask you a question, uh, say if I ask, what do you think that how is it possible or what is the likelihood? Now listen my question carefully. What is the likelihood that human lives for 500 years on this earth? My question is, what is the likelihood, what are the chances that any human, I'm talking about a particular person, any human lives for 500 years on earth? I'm talking about the person like me and you. I'm not talking about the humanity here, but the human as an individual. So what do you say? What are the chances? Guys, you have to be interactive in this session.
Probability 0.
Probably means near to zero. Very good. Somebody has given me an answer. No, almost zero. Zero chance means negligible. May I call it Zobin? Negligible?
Yes, yes.
Yeah, thank you. So why did you give this answer? Can you give me your thought process behind that? Yeah, Kamranji, want to say something?
I heard about time dilation only.
Okay, time dilation. Actually, we have not seen anybody living for 500 years. That's why we can't imagine. First thing. Second is, let me write your inputs. First, you said, that, as we discussed, that no proof, no prior proof. There might be people, actually, there were people who were living for 2000 years, 500, more than 500 years, but they were Rishi Munis from our ancestral part. But we have no direct footprints of them. And second thing, if I discuss, do we have such a kind of food habit? Are we taking a good food such that we can live for 500 years? So I would say bad food habits. Bad food habit is one of the logic behind this. Anything else, if you can think about that, if this would remain, then chances are definitely zero. What is one more thing? Like nowadays, we all are quite engaged in a very fast life, morning to evening. Yeah. Somebody has given some answer, please.
Lifestyle.
Lifestyle. Very good. Thank you, Abhilash. Abhilash has given?
Yeah.
Yeah, thank you, Abhilash. Modern lifestyle. Modern lifestyle. So, see, these are certain things that is not allowing a human to live more than a 5 year or at least to 500 years, because you won't believe all our organs are actually meant for living around 400 to 750 years. All your kidneys, gallbladders, heart, and spleen, means whatever organs are there inside, they are meant to live for more than these many years, provided you give good food, you do exercises, you uh, follow certain processes in life, like getting up early and slowing down, means going to the bed early, early to bed, early to rise. So we are not following this. It means now we have 200% sure, we can bet on it, that any person living on this earth will not go till 500 years, and we are going to win that bet. This is the thing. So this is the actually opinion, or means these opinions has come from these many supporting documents or supporting values. So we are not doing a we are not sharing our gut feeling. We are not doing we are not making a say chance out of it, like say we are not doing a random guess. Okay, for this question we are not making a random guess, not making a random guess, but we are very much sure about these backed processes, and hence we say that the chances are zero. Now, there only the situation of probability comes into picture. So see here, it is written, probability is the mathematical study of chance. See here, chance. and uncertainty. So what we just looked for is chances. But this chances, if I ask you a question, Abhilash ji and others, is this a qualitative or a quantitative guess? When I said a chance, is it a qualitative word or a quantitative word?
Qualitative.
Qualitative. Thank you. Why? Because there is no mathematical interpretation behind this. So sooner I said mathematical study of chance, it means I am doing certain qualitative analysis, and this qualitative analysis is not yet backed by any mathematics, which is supposed to be done. So here the probability came into picture, which provides a mathematical interpretation. See, here it is written, it is not written a study of chance. It is saying mathematical study of chance. Yes. So mathematical means we are saying that this chance, or say there's one more word to it. Whenever we say chance, I would also say, let me use a different color. So this chance can also be represented as a likelihood. Have you heard this term before? Likelihood. Yes,
Yes.
or no? Yes.
Yeah,
So,
this likelihood.
yes, this
I
likelihood.
usually use
See,
it in shifting.
okay, Abdauji, great. So whenever we say what are the this likelihood, what are the likelihood, what are the chances, so such things are usually being used when we are sharing certain possibility, yes or no, certain possibility
Yeah,
of something.
certain possibility.
Yeah, so this likelihood is representing the possibility. Tamil Sevi, please mute yourself. Tamil Sevi, please mute yourself. You are not talking to me directly. Tamil Sevi, mute yourself. So possibility. So now why we are studying this? Because we take actions, we sometimes take a decision on the basis of our gut feeling. Okay, on the basis of a gut feeling. But many a times that gut feeling go wrong. So if I write your gut feeling, it is actually an intuitive thing. Intuition, let me give it a proper name, intuition. So you said, okay, I feel like going there, so you went there, but you did not calculated anything. Similarly, if you see, say suppose if I make a road here, this is a zebra crossing, suppose it's a zebra crossing, say this is your zebra crossing and you are standing at this point and you are supposed to pass this zebra crossing and some vehicle is coming from this end. So what will happen? Are you going to measure the speed of this vehicle? Yeah, Tamil Sevi, please mute yourself, else I have to remove you from the class. Tamil Sevi, mute yourself. Athira, if you could, yeah, thank you. So this particular vehicle is coming towards you and it is having certain speed and the distance from your zebra crossing. So are you going to measure the distance and the speed and then you take the decision ever? Yes or no?
Yeah.
Do you measure the speed of that particular vehicle from your speedometer and go and calculate the distance from the inch tape? Do you do that?
You just calculate it by your head.
Yeah.
Imagine.
Very good.
That
So
the speed of the car.
Imagine.
Very good. That imagination is actually called estimation. We call it estimation. Okay. Means you just took a rough value. That, okay, if this vehicle is coming with such a speed and this is the only distance, should I move ahead? Should I go by walk or should I run? So similarly, this thing here, you are not taking any quantitative measure, but you are only believing upon your gut feeling, intuition, and your brain signals. So such things, gut feeling, intuition, and estimation, when they are given a quantitative support, hope you are getting me. Quantitative support, the quantitative support means the mathematical support. So the study of the quantitative supports towards the chances of certainty, uncertainty, is actually the probability. Hope you would have made sense out of this. Yes or no? Because every day it is happening, man. Every day, in every situation. Okay, say sometimes it also happens you are about to start your class at 7 p.m. or 7:30 p.m. in your country, and you are doing some shopping, grocery shopping or a market shopping. You are into some businesses, so you do the things faster in such a way that you should be available in the class. So what you are doing, you are estimating the things, you are actually applying the mental cognitive ability in order to attend a event. So that is again a probability, like likelihood, that what are the chances that today Sanesh, Abdauji, Sobin, Akhilesh or Abhilash are going to join the class. What is the probability? So this probability will be calculated, or this likelihood or chances will be calculated from the past attendance first. Second is is there anything happened to them or no? And there are many factors. So now onwards, we will be focusing upon how the probability to be reached upon. We won't directly jump to the mathematics, but we will try to understand that where from this has come. If I give you this thing, just read it out. It says it helps us understand and quantify. See the term quantify. It helps us quantify the likelihood of events. There are events, we will see what is event, occurring, the events is occurring from scientific experiment. So we found two things here. One is event and another thing is experiment. So what we are doing an event. Okay, but it is an experiment where from I speak something, you speak something, you look my screen, I look at you, I choose certain red pen or blue pen or yellow pen. So what is this? These are the events happening in the experiment. So we are going to discuss that very thing. So here again, the meaning and the concept shall be kept very, very clear, such that from today onwards, you won't feel difficulty in order to understand the probability. So it says, now see, the things will go term by term. And when we complete it, we will learn something which is an accumulation of it. Like the probability refers to the chance or likelihood now I would of a particular event taking place. Now I would like to add one adjective here. So I would say probability refers to quantifying the, should I write it? Does it make sense? Quantifying the chance or the likelihood of a particular event taking place. Now you might ask, what is the event? What is the event? I don't know what is the event. So here is the event says, after the probability definition, event is an outcome of an experiment. Some experiment happened, and event came the output. Now what is an experiment again? So experiment says that I am a process that is performed to understand and observe the possible outcomes. Now, here is a trick. Here is a switch between the things. If I say an experiment, my dear, if I say an experiment, what do I mean? If say suppose there are only two things by which experiment can be done. Either you are doing an experiment, either you are performing an experiment, you are performing an experiment, and or there's a second situation that you are actually observing somebody performing the experiment. So you are only observing, or must say you are only observer of an experiment. Hope I make sense. So see what is happening here. It says experiment is a process that is performed. If that is performed, there must be someone who is performing it. So either you are performing it or somebody else is performing it. So if you are a performer, I'll say you are performing an experiment. But if you are not performer, you are only witnessing it, then you are the observer. Like say you are hope you must be, most of you might be able to brew coffee or tea, might be able to brew coffee or tea by yourself, or you might, few of you might be a cook or might be loving how to cook. Yes or no, Abhilash ji?
Yes.
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 So in that situation, what is happening? In that situation, you are actually doing an experiment. Yes or no, Sayyid Sabir?
Yeah.
You are doing an experiment. You took the pan, you added a water and the tea, the spoon of sugar, then upon the ginger if you love, and you are actually steering it in the till the taste comes, or you know how many brisk effervescence to take the upside of the tea or the coffee. So this is how I brew the tea. That's why I know the process. So there you are the performer of an experiment. But if you are an observer, must I say suppose something, say if I like a sunrise, are you able to do the sunrise? No, we not at all. So sunrise, if you are observing the sunrise, so we are the observer to the sunrise, or you may also call it sunset, sunrise or sunset. So here, what are the things you observe? The question is this, because after an experiment is performed, there should be a data collection happen. Because see here it is written, experiment is a process that is performed to first understand that what is happening and observe the possible outcomes. This outcome is actually the data collection. Data collection. Like, and that data could be anything. That data could be quantitative, qualitative, cognitive, means that might be numerical, that might be say categorical, that might be intuitive, that might be emotional. Like if you are observing the sunrise or sunset, so you might feel good in the morning, and may I say you becomes nostalgic, about some of the events in life. Yes or no? You might see the sunrise amidst the clouds are there and sunrise is happening. You might go for sunrise and receiving the vitamin D, because we receive the vitamin D from the sunrise, or sorry, the sun rays. Then you may also observe the color of the atmosphere, or may I say color of the sky. Usually the reddish orange color comes. So see, these are the inputs you received. These are the actual data you collected. Some data are emotional, some data are cognitive, but there might be a data which is useful to you directly, like vitamin D. You may say that, okay, what is the direct receiving from the sunrise is actually the vitamin D to your body, which is again happening in your DNA and helping it the life to happen. So whenever some experiment is done, some outcomes used to come. And the set of all the outcomes, see, let me use a different color. When we say the set of all the outcomes, you have one outcome, then second outcome, then third outcome of an experiment. After you did an experiment and all outcomes came, which you have made a set of it, we call it a sample space. Sample space. I think we discussed about population and sample. Population is a big thing, and sample, we take something out of that. So we are talking about space in which few samples are being arranged, and how the samples are collected after some outcomes had come from an experiment. That experiment could be, say, suppose whirling, say, suppose cyclone has come. So the cyclone is whirling in nature. So you see the helical motion. You see the helical motion on the cyclone. There might be a cyclone that destroy the things, but there are only few insignificant cyclone that you may enjoy while you were kid, or say you are playing with your friends, and some cyclone came and all the sand, all the soil or the mud of that particular place just went along with the cyclone. So you observed that. So what is the, again, a probability that or a chance that this cyclone comes or no? Or say, suppose if the atmosphere go likewise, you will always remember that such a motion in the air happened, and such a cyclone or a helical motion came. So there might be a possibility that it might come again. So this is how we are doing the experiment, observing the experiment, and whatever is the experiment, we are collecting all types of possible outcomes, and we collect it all together. And when we collect it all together, we call it a sample space. And from the sample space, we do something where from the probability comes. So if you say, should we move ahead? If any doubt here? Okay.
Yes, sir. Go ahead.
Yeah, thank you. So this sample space and events are defined as, say, it is written, sample space is the set of all possible outcomes, which is the color, all possible outcomes of an experiment or an observation. So lines are very much important. And mind it, whenever we say set, you remember in mathematics, set is defined like this.
Yes.
Set. And what is the quality of this set? Can anybody give me an answer to that? Quality. Yes, guys, quality. What is the quality? Why do we use set actually?
We can put data inside, sir.
Okay, data can also be put inside the list also, Ranjit. Inside the parenthesis also.
Yes.
Why not? Why set only? See, such type of questions should come to your mind if it is not coming yet. Any idea? Yes or no? I may consider the answer from people who have attended my machine learning classes. They might be knowing. Sanish, any idea?
Sir, input code.
Input code is fine, but I'm asking a fundamental question that, okay, say suppose, okay, let me give you an instance. Say suppose you want that your data should not change after you have put it once out of, in the Python, out of tuple, list, set, dictionary, which data structure will you use? Have you learned this? Suppose there's a possibility that you don't want your data to be changed further. So you created a data and that is final. You want no amendment, no alteration, no modification in your data set. So you have to keep your data in certain type of data structure that allow no modification further. Yes or no? Similarly, this tuple is being used for that. So the tuple, we say the tuple is immutable. Immutable means you cannot change the data in the tuple. But if you want your user, your client, or your say stakeholder, they can change the data or they can modify the data, you go for the list. And we call the list is mutable, means you can do any modification in that. But hold it, whenever we need a data which is non-duplicate or unique, whenever we need a data which are unique or non-duplicate, we go for set. So say, what is the meaning to that? Say if I write 1, 2, 2, 3, 4, 4, if you take the output of it, the only answer come as 1, 2, 3, 4. It do not store the duplication. Hope you understand that why I'm using the term set here. Yes or no?
Unique
Yes.
value.
Yes, unique value, Sanesh. Unique value. Sumi Lia has asked, ki, hi sir, can you please describe today's session from the start? Seriously, I couldn't get what's your question. I'm new to this session. So please give an idea about this topic from the beginning. Okay. Sunelia, actually, we are running with the time. So I would say the topic is simply a probability. And I have given the glasses to the audience that how not to look the probability from the mathematical aspect only, but look it from the logic. That's why we started our discussions like that. And we have started the new topic today. That's why it is easier for you to join, or it's easier for you to comprehend. Else, if you would have joined the next class, it might not be possible. So for the time being you have left, or for the time being you could not join, please look for the recordings. It is available, or it shall be available on YouTube. Okay.
Okay, thank you, sir. Thank you so much.
Yeah. Well, actually, your means this what is this? Audience usually do not chat. So somebody has given on chat. It means someone want to ask something. Thank you. Okay, great. So here,
Sorry, sir. Actually, I don't want to interfere in the class. That's why.
it's okay. It's okay. It's okay, Sumi. Actually, you have been to first time, so you will be compatible in the
Yes, sir. Actually, I don't have any business background or something. That's why I just asked the questions.
It's okay. It's good. Asking a question is good. Even they should learn from you. They don't ask question. I have to ask question and answer.
Always like
this.
this.
Okay, sir. Thank you. Thank you so much.
Okay. So we are talking about the sample space, and minded guys, the term set is used. And here, whenever we say set of all possible outcomes, now I'm going to give it a mathematical aspect. I have created a symbol for set, and now I'm writing inside all possible outcomes. And now we know this outcome is coming from some experiment. So when there might be a possibility that in the all possible outcomes which might occur out of an experiment, they might be duplicate. Yes or no?
No duplicate.
They might be duplicate. There are the situation that sometimes same answer is coming out of an experiment. Same answer is coming. Like, hope you remember in your physics days or chemistry classes, when you do certain experiments. So we do an experiment at least 5 times, such that we arrive to a solution, and we give on an average a precise or an efficient answer. That's why there was a situation when duplicate answer comes. So in order to remove these duplicate, may I say, to remove these duplicates, we use the term set. We use these terms set. This is the mathematical and qualitative aspect. Both I have covered in the one line. Then it's now let's discuss about something else which is called event, because possible outcome will only come from event. So here it says events are subsets of a sample space. What does that mean? If I change the color and I write here, if I write sample space by S, if I denote sample space by S, and I write event 1, comma, event 2, comma, event 3, and so on till event n. Okay. So this means that every event, mind it, every event is a subset. Subset means part of the set, part of the set. So is a subset of whom? Sample space, capital S, sample space, representing a specific outcome. Mind it, specific outcomes or a group of outcome we are interested in. Now the point or the time has come that we discuss the events. We discuss the events. Say here, okay, let me just give you one simple example as you understand. Say suppose you have a big room. In this big room, or may I say big house you have, in this big house, and consider this house as your sample space, whereby 3 rooms are there which are being allocated for the family members. So this is allocated for family members, family. But there are 2 rooms, let me indicate them with a different color. So say there are 2 rooms, one room this and another room this, which are allocated for guest. Like we all have, usually if we are upper middle class, then we say we usually keep the guest room. Some people also have guest houses as well. So we have kept the guest room for guest in order to accommodate the guest. So what would I say in this sample space? What is an event? May I say that these two guest rooms, G1 and G2, these 2 guest rooms are 2 events from this big sample space, whether other than the family members' rooms. So if I have to create the sample space for this big house, I would say event 1 is family room F1, then family 2 F2, family 3 F3, 3 rooms, comma, separated by comma, and there are 2 guest rooms G1, comma, G2. So this is a sample space out of it. So in this sample space, every room is an event. Every room is an event. Why? Because room number 1 is occupied by a different family member. Room number 2 is occupied by a different family member. And whenever the guest comes, they are again being occupied by different type of guest. Hence, we are not repeating anything. First thing. Second is because all of them are having different capabilities, different characteristics, different color of the room, different size of the room. Even the size of the room is okay. The position of the bed in the room is different, or whatever stuff is kept inside, the overall room is different. Hence, all the rooms shall be served as a different event. Is this understood or no?
Yes.
Yeah, thank you. Because then only we can go towards mathematics. So if that is clear, let's take an example. Okay, let's take an example. So this example is going to help you a lot. So it says, in a manufacturing unit, 3 parts from the assembly are selected. So say there is an assembly. Assembly means you have assembled some machine part, and from the assembly, 3 parts from this assembly, say one part is this, another part is again you have, and the third part is again you have this. So part 1, part 2, part 3, they are selected, and you are observing, mind it, you are not the experimenter, you are an observer here. So you are observing whether they are defective or non-defective. Question is clear? You have to observe whether if you take this first part of the assembly out, you have to observe whether it is defective or non-defective. Simple. And the same thing you have to repeat it for part number 2 as well as part number 3. Is the question clear? What is the task behind this?
Yes.
Yes. Now your task is, the main task is, in order to observe this, when somebody is taking part 1 observing defective non-defective, taking out part 2 observing defective non-defective, taking out part 3 observing defective non-defective. So you have to create a sample space, determine the sample space. So what is the sample space? Can you recall from the past, just previous slide? Set of all possible, what should I write here? Set of all possible
Outcomes.
outcomes. Thank you, Genji. Set of all possible outcomes from an experiment. From an experiment. So experiment is done. What is that experiment? Somebody took 3 parts out from an assembly, and you have to observe whether it is defective or non-defective. So now these possible outcomes, you have to prepare a set. Now deep dive that what are the possible outcomes here? What are the possible outcomes? So would you like to help me out? That what are the possible outcomes you can observe here? Possible outcomes. Say if I make a list of possible outcomes, may I say that, okay, let me give you one hint. Say if I take this first one out here, so this is either defective or non-defective. So similarly 2 and 3. So if you take all the 3 out, you have taken all of them out. Now you have to prepare the combinations of defective versus non-defective. Like the first one, if I give, there might be a possibility that all the 3 are defective. Yes or no?
Yes. Yes.
Likewise, I'm asking the outcomes. So this is the first possibility, comma. Next possibility says that 2 are defective. So this says all the 3 are defective. And this is the worst thing, worst case. So I'll call it a worst possibility. The second possibility starts that, okay, suppose there is 1 good, means 1 non-defective, and 2 are defective. So how to write that is a point. So say suppose you have taken first part first, and second part second, third part third. I'm talking about the sequence. So the first part came defective, second part also came defective, but the third part went good. The third part was not defective. So I'm writing G for good. I'm not writing ND because again it creates a confusion. So I'm writing G for good. So
Good.
how many times how many times you can create the possible outcomes of 1 good and 2 defective? What would be the number of combination? Here, this is the first one, this is the second one, this is the third one, third part. So what are the other ways that good can come and two defective is still there? What are the other ways? Please give me an insight here. Hope you got my question.
1 good and 2 defective.
That is fine, Kunal. But I'm saying, okay, you are saying 1 good, 2 and 3 are defective.
Yeah.
Okay, thank you. Good, great. So first one becomes good and rest 2 becomes defective. Is there any other possibility?
Yeah. The second one good and first and third is defective.
Very good. So second one becomes good and first and the third becomes defective. Hope now you are able to analyze the outcomes of an event. So this is the possibility of
One is good.
two defective.
Two
Yes.
defective.
Yes. Yeah. Or one is good. Very good. So again, likewise, there might be a situation that two becomes good and one becomes defective.
Right.
So let's make it. So GGD, the first two becomes good, or first and the last becomes good, and second and the last becomes third becomes good. Is it okay? Everybody understand?
Yeah.
Thank you, Kumar. So this is again the possibility. So, and there is there any other possibility?
All
Yes,
things are
sir.
good.
All are
three
good.
can be good.
All are good. Very good. Great. So GGG, all three are good. So how many events had happened? 1, 2, 3, 4, 5, 6, 7, and 8.
Eight.
8 events have happened. So out of these events, my dear, which one is the best case? Means best possibility. One. This.
One.
I'll call it a best case. And this was the worst case because all were defective. Similarly, this is the best case. This is the second best case. This I'll call it as third best case because two are defective, and that is the worst or the fourth best. Always be hopeful. At least you are getting the part. Great. So see, have you seen that how beautifully, without even using the concept of probability, we have created this sample space. So there is one more way in order to create that. If I give you an instance, I can create my sample space. There is one possibility I may write that there are, say, 0 defective, means GGG. I'm writing the count now. 0 defective, 1 defective, 2 are defectives, and all are defectives. Is it okay? This is also one of the way I can go for creating my sample space.
Yes, sir.
Great. So let me make them defective. But this doesn't serve the purpose. When I say 0 defective, you might not be able to find then how many are good. Then again you have to go to reading the whole question. Again read out the question. If I write this, so never ever give your sample space in terms of counting. This is a counting things. So do not provide ever your sample space in terms of counting, because it do not give the real picture that what is happening behind the scene. If there are 0 defective, then how many are non-defective? This is not clear from this. But sooner you say 1 is defective, then it is not even clear that which one is defective. First one, second one, or the third one. Similarly, if 2 are defective, then which 2 are defective? So this gives an unclear picture. But this gives a very good thing in order to create all these possible outcomes. Yes or no? It gives a very good impression or a base in order to create these outcomes, possible outcomes. Understood? So here from we create the sample space. So our sample space would be, let me give you through this, our sample space would be this. This is our sample space. Please have a look. Is there anything missing here? We have all the 3 non-defective, 2 are non-defective, only 1 is non-defective, and all of them are defective. So we have 1, 2, 3, 4, 5, 6, 7, and 8. So this is, my dear, our sample space. So always create your sample space in terms of events. So what we learned, create our sample space in terms of events. Now, why I've said so? Because if you only want to take, say, suppose few events, then it is easier to fetch from your sample space. Like here it says, let E denote the event. Here it says, let E denote the event of getting at least 2 defective. Why it is talking about 2 defective? Because we have asked in the second question, the event of getting at least 2 defective, parts. So if for the time being, if I forget about at least, suppose if I forget about at least, do not look at this, and I ask the event of getting 2 defective part, how many events can you find here having 2 defective part?
4.
Defective, man, 2 defective.
3.
Only 3, very good. Now you understood the question. So only 2 defective, this one, and the third one. So 3 are 2 defective. But whenever I say at least 2 defective, means we are going for more than the 2. If there are more than 2, there should be 2, but more than 2 are welcome. So the worst possibility also comes into picture. So the same thing it is talking about. Let E denote the event of getting at least 2 defective parts. This implies E contains 2 defective and 3 defective. Looking at the sample space. Now look here. Make your eyes here. So looking at the sample space, you can choose them. So you can choose this one, and the last one. So, and this has come into your event E. Actually, they all are event. They are event 1, event 2, event 3, event 4. So 8 events are there, out of which these events are being considered for at least 2 defectives. But if you would have created the sample space with 0, 1, 2, 3, you won't be able to get that. Hope I make sense. So here from, what did we understand? That event is always a subset of a sample space. So if you are fetching certain event, it will be present in your sample space. Hope this makes sense to you. Now, sooner this is being understood. Any doubt here in this? If you are in the doubt, any doubt, please ask. Everyone. Sanesh, Abdauji, Abhilash, Betsy, Jackson, Prakash, Janji. Okay, somebody joined. Sumilia, any doubt?
Hi, sir. Sorry. Actually, I couldn't understand any of the session. Actually, I couldn't get anything today. I'm sorry,
Okay.
sir.
Okay. You joined very late. I think you joined very late.
Yeah, and actually, which subject you are studying? I mean, teaching, sorry.
Actually, it is a mathematics for the time being. It's a mathematics, and we are learning how to see the world from the glasses of probability.
That means what, sir? Actually, I didn't get.
Okay, you didn't get. Have you never been to this term probability ever?
No, sir, I know.
No worries. Say suppose today whether it
Can you
rains
make
or
it
no.
simple?
Yes, I'm
Yeah.
making it. Say suppose if I ask you whether tomorrow would it rain or no, how do you check?
By seeing outside, or maybe
You have your application. Those
yeah,
apps
in my phone.
guide
Yeah,
you.
yes.
So how those applications are recommending you whether the rain will happen or no? There might be certain algorithm running behind.
Yes, sure. Yeah.
So those algorithms, Sumilia, those algorithms are running on the mathematical concepts of probability.
Okay. Now I understand.
That we are learning. Like, say, suppose here I said that whether tomorrow sunrise happen on time or no. It will depend, actually it will happen, but whether we are able to see it, it is only dependent. If there would be a cloudy, we won't be able to see that. But who will decide whether the cloud will be there or no? Again, if you look out, or if you see your app, or you simply estimate, or if you are a weather forecaster, that helps you a lot. So this is what we are saying, that like you, if I ask you what's the probability, what's the likelihood, what are the chances whether you fall ill tomorrow or no, you will say, no, I'm perfect, nothing has happened to me, I'm feeling great, I had my food, I walked today, I had my exercise done. So it means you did certain things, so there are less chances that you fall ill tomorrow. Understand?
Yes, yes.
So such things we are studying.
Okay, sir. Okay.
Yeah, thank you. Yeah. So let's, because now actually the mathematical aspect was concerned, but time is not allowing us. But for the time being, let me give you certain things. Say, suppose, how to define a probability of an event. To define the probability of an event, we write it like P of A. So here A is your event and P is the probability. And mind it, this probability is simply called as a quantitative measure. Quantitative means by which you can measure, actually. Quantitative measure of chances or likelihood. Likelihood. Please mind the spelling. Or the likelihood. So this is how to represent them. But if you are asking that, okay, how does the probability of an event is calculated? We will go simple with the mathematics helps us. This says number of ways, I'll write number of ways that are favorable. Number of ways that are favorable to the, say, occurrence, to the occurrence of the event A. To the occurrence of event A means number of ways that are favorable divided by total outcomes. Okay, total outcomes in an experiment. Total outcomes in an experiment. And you know now this experiment will give you the sample set, sorry, sample space. From this sample space you have number of events, and if you are seeking for event A, you can go for out, means writing the number of events which is you have been asked for, and divide by the total outcome of an experiment. Say suppose if you have been asked that what is the probability of here, what's the probability of here two defective, what is the probability of having two defective pieces from an assembly. So what are the number of ways that favorable to the occurrence of two defective? See here, how many two defectives we have? 1, 2, 3. Only two defective, not at least, only two defective. So we will write 3 here, which are number of ways that two defective can come. So what are the number of ways? 1 may come defective, 2 and 3 are good. 1 is good, 2 and 3 are defective. And say 2 is good, 1 and 3 are defective. That's why 2 defective may come. Likewise, hope it is understood by all now. So 3 divided by how many total outcomes are available to us? Count and get it to me. Total outcomes. 8. Very good. So there are total things came out of it. So the answer came by 3 by 8. So what should I calculate with the percentage here? Please get me the answer in percentage. 8 to the 16, 8 3 is 24, and 24 and 6, 8 7 is 56, 4, 8 8 3 is 24, 8 4 is 32. So 37 point. So actually it will come as a 0.374. It will come as 0.374. If I multiply by 100%, this will give me an answer as 37.4% is the likelihood, chance. Okay, so 37.4% is the chance that 2 defective pieces should come. This is how we understand the thing. Like you say, okay, whether it will rain or no. Okay, I am looking, gazing again to my cloudiness and saying 50-50, it will happen because I feel half of the sky is clear and half of the sky is with the cloud. So I'll say 50% chance. But if I'll say most of the sky is clear, only few of the sky is not clear, I'll say, okay, there is 90% chance that tomorrow there won't be rain, or 10% chance that the rain would be there. Either way, can you get it? Either way. So this is how to calculate the probability. So in our next class, we will be continuing with the same event, and we will be finding the multiple types of probabilities or quantitative measure of the likelihoodness. Any doubt? Should I stop sharing?
Hi, sir. I have a question.
Yes, please.
In which subject this topic belongs to? Today's topic.
This topic belongs to, it belongs to the life, Sumi. Why? First of all, actually we are studying the things in order to make ourselves aware about the technology. Say suppose if I give you this subject, you will fail counting that. Like machine learning, we go for recommendation system like OTT platforms. Right nowadays you are being subjected to, say you are watching a movie on a YouTube or a Netflix, similarly you will be recommended new movie. How they are doing that? They are collecting their your preferences, your choices, your abilities to love the genre, the drama, the action, everything. So these topics are being helping big giants in order to do businesses. Okay, so I actually take classes here at Eduwing in order to support the learning of application rather than only going for subject wise thing. That's why people just enjoy learning. Sumi, does it make sense?
Yes, sir. I understand.
Yeah. So today's class actually belongs to open your eyes towards learning the concepts of probability in mathematics. It is actually belongs to the mathematics. The subject belongs to the mathematics, but it is applicable throughout the world in terms of business applications, whether it's a machine learning or it's a deep learning or it is a OTT platforms, or you call it as a GUI interface where you actually touch the screen and it works for you. So why it is working for you? Because some probability is being calculated over there. You go to certain e-commerce website and check whether shall I be able to buy this or no. So they provide you the inventory based upon their inventory, whether this product is available or this product is not available. So they check in their inventory. So they count the complete sample space and they give you the probability. Okay, there is a higher chances you get the item. Have you heard this about? So likewise we learn that. So guys, the time has come. Please open your what is this camera? Let's have your beautiful photos. Great. People are doing this. Kunal seems happy today. What happened, Kunal? Hope I made your day. Janji, everything good?
Yeah, everything good. Actually, when we study the sets in mathematics in our previous in school days and all, I was wondering where we will use in practically. So when you take this class, I was that time I was not much interested to study the maths, because where we will apply this? What is the use of studying all this one? So when you said this is the practical application, so it's very good. Thank you.
I actually take practical things to be applicable because I do such a work where I have to apply all the learning. I used to train people. I used to do projects for a government or a non-government things. So I have to run the sets, or may I say I have to run the data set with 50 crores lines. So imagine 50 crore observation and you are running it. And if the memory is not allowing you to do, or say if your processor is not allowing you to do, how would you manage? So I have to do the optimization, applying the mathematics. So that is why I could able to answer. Thank you for your experience that you discussed. Okay, let's make a thumbs up. Let's call it a day and do the good things in life. It's great. Thank you, Abdauji. Thank you all for your time, and hope we meet again in our next class. Thank you, Zahir. I have taken. Yeah. All the best.
Okay, sir.
Take care.
Thank you, sir.
We are going to meet. Okay. There might be a possibility that I could not take the next class, that is on the 1st of September. But after that, we will definitely come. So
Okay.
don't be hopeless.
No, no.
Okay.
Sure, sure.
Bye-bye.
Okay, sir.
Bye.
Okay, sir. Thank you.
Thank you.